Hello. In this video lecture, we're going to answer some problems that involves growth of a function. But before that, let's have a review. So we all know that a function could be represented by big O notation, or O at g at x. OG at x or g at x should be bigger than function at x. Okay, wherein this will be true, wherein we define c and k. C is the one that we multiply with our function, and the k is the minimum value of x, wherein c at g at x will be equal or greater than the original function. Okay, so let's have this problem. Find the least integer n such that f at x is O x sub n for each of these functions. So we have 4 equations, and we're going to determine the value of n. Okay, so let's start with letter A. Function at x is equal to 2x squared plus x cubed log x. So first, we need to define, or we need to determine which among these two terms is greater than the other, or bigger. Okay, so is 2x squared bigger than x cubed log x, or x cubed log x is bigger than 2x squared? So x cubed log x is bigger. So therefore, 2x squared could be replaced by the equation of x cubed log x. Okay, since it's the bigger term. But our question, it should be x raised to n. So therefore, we need to remove log x. So we need to find an equation in terms of x, wherein x cubed log x is lower. Okay, we need to find x sub n, which is bigger compared with the x cubed log x. Okay, so let's start with x cubed. Can we replace x cubed log x by x cubed? Is x cubed greater than x cubed log x? Definitely no, it's false. So therefore, x cubed is not, it will not be used to replace our x cubed log x. So how about x to the fourth? Is it bigger than x cubed log x? Yes. So therefore, the whole second term could be replaced by x to the fourth. Okay, all x raised to something will be replaced by x to the fourth, same as with the first term. So now we have 2x to the fourth plus x to the fourth. Okay, and then add, we have 3 to the x to the fourth. So based on this simplified equation, n will be 4, since it's the exponent of x. And for c, which is the multiplier, it's 3. And the minimum value wherein 3x to the fourth is greater than or equal compared to the original value, k is 0. Okay, so therefore, this is our final answer. N is equal to 4, c is equal to 3, and k is equal to 0. So that big O notation is bigger than the original equation. Okay, letter B. So we have 3x to the fifth plus log x raised to the fourth. So let's check which is bigger. Is it 3x to the fifth or log x raised to the fourth? It's 3x to the fifth. Therefore, log x4 could be replaced by the x to the fifth. Okay, not the whole 3x to the fifth, just the x to the fifth. Okay, so it's bigger than the log x to the fourth. So it will be our new equation, 3x to the fifth plus x to the fifth. And then just add, we have 4x to the fifth. And what is our n based on this? It's 5. How about c, the multiplier? 4. And how about k, wherein 4x to the fifth is equal or greater than the original equation? It's 1. Okay? So this would be our answer. And again, c, k, and n could be you could obtain a different answer as long as it will be a bigger value. But don't forget we are looking for n minimum. But for c and k, you could change it. You could have a different c or k, because c and k, if you're going to increase k, there will be a corresponding c for that. Okay, so my answer is one of those answers. Okay, letter C. We have function at x is equal to x to the fourth plus x squared plus 1 divided by x fourth plus 1. Okay, so if we have this type of equation, we're just going to divide and get the final equation. Okay, that's our solution. But for me, before doing the division, I'm going to evaluate the numerator and denominator. So what can we say if x become bigger near infinity? What term is the dominant term for numerator and denominator? If x is near infinity, which among the terms in numerator will be the dominating term? Same as with the denominator. It will be x to the fourth. Am I right? Both for numerator and denominator. So if we're going to divide it, x to the fourth divided by x to the fourth, so we have 1. So what is the exponent of n to get 1? It's 0. Okay? Therefore, n is equal to 0. Since x to the fourth divided by x to the fourth is 1, near to 1, okay? So what is the equivalent of x sub n equal to 1? So n should be 0. So now, what will be the value of c and k? Okay, so let's check first what is the dominant for the numerators. It's x to the fourth. And for the numerator, a denominator, we want to make it smaller so that we are assured that the result of our evaluation is it will become bigger compared with the original equation. So if we have a denominator, make it smaller. So how are we going to make it smaller? By removing 1. Am I right? Okay, since it's a constant. Okay, so for the numerator, our new equation will be, so since x4 is the dominant, so replace x squared and 1 by x to the fourth. So we have x to the fourth plus x to the fourth plus x to the fourth. And again, we're just going to minimize the value of the denominator so that the whole equation will have a bigger value. So that's why it will just become x to the fourth. Okay, so divide it, x to the fourth, 3x to the fourth divided by x to the fourth is equal to 3. And this is true if x is greater than 1. Okay, so therefore, our c, after the division, c is 3. How about k? Okay, it's 1. Okay, so the minimum value of k that will make the statement correct, wherein big O notation is bigger. So the minimum value of k is 1. Okay, how about letter D? It's almost the same as C. Okay, so we have x cubed plus 5 log x greater than x to the fourth plus 1. So we have 5 log x and x cubed with the first term, or with the numerator, we have x to the fourth plus 1 for the denominator. So let's check first for the numerator, which is bigger, the x cubed or the 5 log x? Definitely x cubed. So any value in our numerator will be removed by x cubed. All x will be will be changed to x cubed. Okay. And how about the denominator? Will it be x4? Yes. Okay. So it will be, so to solve for n, okay. So again, since x cubed is the dominating, x to the fourth is the dominating term. So when we have an um, um, we have x near to infinity, 5 log x is negligible, same as with 1. So we only have x cubed divided by x to the fourth. Okay, so therefore the result is 1 over x. So our x sub n, or x raised to n, our n is -1. So again, how did I get x cubed? Because near infinity, 5 log x is negligible. Near infinity, 1 is negligible. So therefore, we only have x cubed divided by x to the fourth. Okay, and by dividing, we found out the n is equals to -1. Okay, now let's proceed with defining c and k. Okay, so we're going to replace, so we need to determine, or we're going to rewrite our numerator in terms of x cubed. So we have x cubed plus 5 log x. So I replace log x by x cubed. And why x to the third instead of x to the fourth? Because we want to make our equation bigger compared with x, or to the original equation. And it is easier to divide if we have the same exponent for the numerator and denominator. So that's why I choose x to the 3. Okay, x raised to 3. Okay. Because instead of having a fraction, it's better to have a whole number. Okay. So simplify, we have 6x cubed divided by x sub 3, x raised to 3. Okay, so therefore, our n, or our c rather, is 6. And if we're going to evaluate the equation, and 6x cubed divided by x cubed should be greater than the original equation, k should be equal to 1. Okay, so therefore, n is -1, with 6 is equal to 6, and k is equal to 1. Okay, again, x to the 4 plus 1 becomes x cubed because of the numerator. By changing x to the 4 to x cubed, we're making the equation bigger, so that's okay. Okay, so if you want to have an x to the 4th, it's okay then, but you're going to have a different answer for the c and k. Okay, so now let's move on with problem number 2. So let k be a positive integer, show that 1 raised to k plus 2 raised to k up to raised to n to k is big O notation and k plus 1. Okay, so this is our equation. We're going to prove that it is big O notation n raised to k plus 1. Okay, let's check. Which among these terms is the bigger term, or the dominating term? It's the n raised to k. So therefore, I'm going to replace all terms by n raised to k. So 1 raised to k will become n raised to k, 2 raised to k will become n raised to k up to n raised to k. So we have lots of n raised to k. Okay, so let's simplify this. How many n raised to k that we're going, how many n raised to k n raised to k that we're going to add. It is based on n, am I right? Since it's from 1 to n. So number of n raised to k is equal to n. Okay, so therefore we could simplify this. Instead of n raised to k up to n raised to k, it will be replaced as, it could be simplified as n times n raised to k. And by multiplying this, we have n times k plus 1. Okay, so this is the notation of big O. So this is our solution. So if you have questions, kindly send me a message. Okay, so thank you for listening. See you.